Hi, let's finish off our science syllabus with chapter 8. The first thing that we want to talk about in chapter 8 is alloy. So what is alloy? Alloy is a mixture of two or more elements with a certain fixed composition in which the major component is a metal. Well, it might sound confusing to you, right? So to understand alloy, we must first understand pure metal. Now, pure metal is only made up of one type of element, meaning they will have the same size. Okay, so let's say this is the atom of the metal. All of them, because they have the same type of metal, right? All of them will have the same size and also the same composition. Okay, so what will happen when they are in solid form like this? Well, you can see very clearly, right? They are layers of metals. Okay, so this layer number 1, layer number 2, layer number 3. Now you imagine if I use a hammer and knock the first layer, what will happen to the first layer? Well, the first layer will start to move, right? The first layer will start to move because, as you can see, the elements, or what we call these atoms, are arranged in a very orderly and neat manner. Okay, so if I hit the first layer, it will start to move, and we call this sliding. Now, think about it. If the metal can slide so easily, can I use this metal to build buildings? No, right? Because the building might start to slide, okay? Or maybe how about to use it to build bridges? Okay, also cannot, right? Because the metal now is not strong enough. So what happens is, in order to prevent the sliding, scientists come up with this thing called alloy, which is a mixture of two or more elements with a certain fixed composition in which the major component is a metal. So let's say these atoms are the metal, and what we do, right, is we actually melt them down. When we melt them down, these metals are gonna move apart from each other, right? So probably now it will look like this in liquid form. Yeah, this very tidy and neat arrangement is in solid form. But when we heat it up, it will start to move apart and become liquid form. And this time, what we do is we are gonna input other metals into it, or we can also input other non-metals. One of the commonly used non-metal is actually carbon. We are going to put in foreign atoms. Foreign atoms are actually other atoms, whether it's a metal or a non-metal, as long as their composition is different from the original metal. So I'm going to label the original metal as pure metal. And the one that we are adding in is known as foreign atoms. And the foreign atom can either be metal or a non-metal. Foreign atom and the pure metal have a different size. Okay, has a different size. And when they are cooled down, what happens is we get a new arrangement. Yeah, we get a new arrangement. And now they are arranged together with the pure metal, right? So the pure metals, when they are cooled quickly, this will be their new solid arrangement. Yeah, it kind of looks like a sunflower. Okay, so let me draw more of this. Okay, so this is the rough visualization of this new thing, right? So this new thing is known as an alloy. So now you compare the alloy picture with the pure metal picture. For the pure metal picture, you can see layers very clearly, right? That's why when we put some force onto one of the layers, it will start to slide. But how about this new arrangement? Can we see layers by layers? No, right? They are kind of jumbled up. They are kind of mixed up. So they cannot slide. So alloy is good because it prevents the sliding of pure metal. Okay, and what are the differences that you can see between the pure metal as well as the alloy? Okay, let's just take a look at them. This is pure metal and this is the alloy that is formed. Well, for pure metals, atoms are arranged in order, right? arranged in order and they are arranged very close together. But the arrangement of alloy is random. Okay, the atoms are arranged randomly and they are scattered and they are in between each other. Okay, for the pure metal, the layers of the atom can slide easily. But what's about the alloy? Well, we cannot see a layered structure. So the pure metal atoms are unable to move because of the addition of the foreign atoms that hold them in place. So they cannot slide. And pure metal, because it's able to slide, it makes it ductile. And also malleable, meaning we can pull them into thin wire and also they can easily change shape. But for alloy, they are harder and they are non-ductile as well as non-malleable. Okay, so a very commonly asked question in SPM will be the purpose of alloying. So altogether, we have three purposes of alloying. The first purpose is to increase the strength and hardness of the pure metal. So increase strength and also the hardness of the pure metal. And after that, it also can have more resistance to corrosion. Okay, more resistant to corrosion, meaning it will not rust easily. Another purpose is it will have a shinier and more attractive appearance. Yeah, more attractive appearance, meaning they will look nicer. So these are the three major purposes of alloying. So again, increase strength and hardness, increase resistance to corrosion, as well as make the metals appear more attractive. And it's good for us to know the few commonly used type of alloy in the industry. And it's also good to know what are the composition in these alloys. Okay, we start off with brass. Brass is actually made up of 75% of copper as well as 25% of zinc. And we are going to use it to make a musical instrument. If you study music, there's a musical family known as a brass family. Yep, so we use it to make musical instruments. And also we can also use it to use in the kitchen, yeah, as kitchen appliances. Next, let's take a look at bronze. Bronze may sound familiar to you because one of the common use of bronze is actually to make medals, right? During the school sports day, yeah. If you run and run and run and you get number 3 in the race, then your teacher will actually give you a trophy made up of bronze, right? So it's made up of 88% of copper and 12% of tin. Okay, now let's move on to copper nickel. Copper nickel. Well, the name says it all. Copper nickel is actually the combination of 75% of copper as well as 25% of nickel. And one of the use is for coins. Yep, for our coins. And stainless steel. Yeah, stainless steel is also something that we use every day in our life. The most commonly used is in our fork and spoon, right? Fork and spoon. So it's made up of 74% of iron, 8% of carbon, as well as 18% of chromium. And we use this in the kitchen, for example, our forks, spoons, knife, and so on. Okay, so let's do one more. Okay, pewter. Pewter is something that Malaysia is very proud of. Yep. And if you talk about Kuala Lumpur, is one of the city that produces tin, right? So pewter is made up of 96% of tin, 1% of antimony, as well as 3% of copper. And because this combination will be soft, shiny, and malleable, is very suitable to for making decorative and ornaments. Yeah, decorative ornaments, as well as household items. Okay, so probably you have heard of a very famous brand before, Royal Selangor Pewter. Okay, so that's it for alloy.